Basic chemistry concepts for a good start in grade 11. The number of moles, definition, and calculation. Definition. The mole, symbol is mole, MOL without E, is one of the basic units of the system, which is mainly used in physics and chemistry. 1 mole is the amount of material in a system containing exactly 6.023 times 10 power 23 entities. These entities could be atoms, ions, molecules, or others. This big number is called Avogadro's number. Relationships that can be applied to calculate the number of moles. The number of moles could be mass divided by molar mass, or volume of a gas divided by molar volume of gases, and this rule is used only in the case of a gas. Number of moles could be molar concentration, C, times volume of a solution, V, used in the case of a dissolved substance. Chemical reactions and stoichiometry. At the microscopic scale, the chemical reaction is a modification of the bonds between atoms, but the atoms themselves are conserved. This is called the conservation of matter. When writing the balanced equation of a chemical reaction, it is a must to respect the rules of the conservation of the material. In order to comply with these rules, a so-called stoichiometric coefficient is placed in front of the chemical formula of each chemical species, indicating the proportions between the species involved and between the species formed. For example, CH4 plus 2O2 give CO2 plus 2H2O. The coefficients 1, 2, 1, and 2 are respectively the stoichiometric coefficients of CH4, O2, CO2, and H2O. In chemistry, stoichiometry is a calculation that analyzes the amount of reactants and the products that are involved during a chemical reaction. Thus, the stoichiometric ratio, or the law of the stoichiometric proportions of the previous equation, that is, CH4 plus 2O2 to give CO2 plus 2H2O, is the following. Number of moles of CH4 reacted over 1 equal number of moles of O2 reacted over 2 equal number of moles of CO2 formed over 1 equal number of moles of H2O formed over 2. This proportionality can determine the mole composition of the mixture at any given instant of time. At any instant of time t, number of moles of CH4 remained equal number of moles of CH4 initial minus number of moles of CH4 reacted. Number of moles of O2 remained equal number of moles of O2 initial minus number of moles of O2 reacted. But before any calculation that is required for the application of the stoichiometric ratio, it is necessary to determine the limiting reactant. The reactant whose initially introduced quantity is fully consumed or completely consumed at the end of the reaction, which means that at time t equal infinity, number of moles of the limiting reactant reacted is equal to the number of moles of the limiting reactant initial, then number of moles of the limiting reactant final is equal to 0. How to determine the limiting reactant? Method 1. Method of stoichiometric ratio. Consider the equation of the previous reaction, CH4 plus 2O2 to give CO2 plus 2H2O. Suppose the initial number of moles of CH4 is 0.4 mole and that of O2 is also 0.4 mole. The stoichiometric ratio of this reaction is, again, number of moles of CH4 reacted over 1 equal number of moles of O2 reacted over 2 equal number of moles of CO2 formed over 1 equal number of moles of H2O formed over 2. Determination of the limiting reactant. Ratio of CH4 equal number of moles of CH4 initial over 1. By substitution, 0.4 over 1 equals 0.4. And notice that the ratio is a unitless. Ratio of O2 equal number of moles of O2 initial over 2 is equal to 0.4 over 2 equals 0.2. Also, the ratio is unitless. Now, by comparison, 0.4 does not equal 0.2, so the initial mixture is not stoichiometric. 0.4 greater than 0.2, therefore, the reactant O2 is the limiting reactant totally consumed, while the reactant CH4 is in excess. It is good to know a mixture is called stoichiometric when the reactant ratios are equal. In this case, the two reactants are totally consumed. Method 2. The table of progress or the table of the evolution of the reaction. This table will be discussed in a next session. Thank you for your attention. See you.